Let's resume our discussion on currying in F# now. We had a previous video where we looked at the add function. We said that we provide that two parameters x and y and we get the sum as a return. So we saw that illustrated by the sum variable here. We call add on 3 and 4 and get 7 as a result. What we saw then is we could call this with just one parameter, add 3, and define this new function here, and that goes from integer to integer, and that stores 3 somehow internally in this original, or this new function stores this value 3 in this original function in some way internally. That was sort of unclear in the last video, and we could then call this with these two function calls here with 4 and 5 respectively and get the output 7 and 8. So in this video, we're going to build upon this a little bit, and we're going to see another way of writing something like this add function. So I'm just going to call this add old for now, and we're going to define a new add function, add x, but I'm only going to give it one parameter, x, like this. And what I'm going to define in here, and let me actually remove this for now. What I'm going to define in here is a new function. We're going to call that sub function, like that, and that's going to be a function of y, and we're going to say that this is x plus y, like so. And then in here, I'm going to return sub function. So, like. And now what I can do is say let add 3 be equal to add 3. Let me execute all of this, and we're going to see what we get from these values. So this one we're not too interested in, but we see that this function here, add, takes one parameter x, and what it does is it defines, when we call it, a new subfunction, and it returns that. So if we look at the signature here of the add function, it takes an integer, that's the x value that we would provide here, and what it returns is whatever we have in parentheses here. So it returns, in fact, a new function. So the return type of this is a function going from integer to integer. Specifically, it returns this subfunction that we defined in here. And this subfunction, as you can see, just takes one parameter y, and it returns x plus y. And x is going to be set whenever we provide a call to this function here. So when we call on row 8, let add 3 be equal to add and then parameter 3, we send the parameter 3 into this function. And what that's going to do is it's going to define what's called the subfunction here. And it's going to say that's a function of parameter y that we haven't given yet. And that's going to be 3 in this case because we provided a parameter value of 3 plus y. And then it returns that function. So the return here is a function, specifically a function called add 3. And we can call this add 3 function on a new parameter. So let result equal to add 3 on the number 4, like that. And just as we saw last time, this will come out to be 7 because this function now, add 3, takes one input parameter 4, and then it already had the other parameter 3 specified, and the sum of those equals 7. So this is somewhat of an explanation for what we saw last time. This representation here is more like what F# uses internally when it compiles the code. So it takes these multivariable functions and it breaks them down into single parameter functions like this. And that's why if you look at the signature for this add old here, you can see that you have x to y to int, or int to int to int if you just look at the types. It's not like int comma int to int. It's an arrow between each one. And you can see that the function signature for this here, the new add function that we defined, is the same as above here, just that we have a parenthesis. But really the flow of execution steps here is the same. And the reason why the function signatures look this way in F# is because it uses this currying approach sort of in the background. So whenever you define a multivariable function, it's going to be broken down into nested functions or curried functions like we described in this video. We're going to keep building on this in the next video, but this is some more depth on how functions are actually stored in F#.